Okay, so a water tank built in the shape of this inverted circular cone. It says it has a height, so from the tip to the top, to the center here, to the top, is a height of 5, and the diameter across here is 6, which of course means the radius is 3. And we've got this scenario. Let's just draw a quick picture. So best you can, or the best I can, I'm sure you can do a great job. Here's my inverted cone. And I'm just going to indicate that from the bottom to the tip, this is the height. And in here, this is the radius. Yeah, could you close that for us, please? Okay, and it says that a water tank is built in the shape of an inverted circular cone, and it's saying that this height is 5 and that this radius is 3. And we're pumping water in. Okay, I'm going to use blue. We're pumping water in, coming in there, at a rate of 1.6 cubic meters per minute. And as you pump the water in, of course, the water level here starts to rise. And that water level rises. Oh, we're trying to find the rate at which the water level is rising when it's 2 meters deep. Okay, so let's go through and look at what information we've been given. Water is being pumped into the tank at this rate. That's telling me the change in volume. So here's my givens. The change in volume with respect to time is 1.6 meters cubed per minute. Find the rate at which the water level is rising. Okay, I'm going to call h the height of the water. So let h equal the height of water in the tank. And I'm going to let r equal the radius of the water. Okay, so just so that that makes sense to us, if I'm looking at this height, then part way down the cone here, so here I'd have a different radius than I have up here. Yeah? Okay, so I'm going to talk about the height of the water and then the radius at that height. So that's what my h and r relate to. Okay? For the tank, the height is always 5 and the radius is always 3. But can you see that the height of the water is changing, obviously, but so is the radius of the water. The radius of the water is not always 3. Okay, what am I asked to find? The rate at which the water level is rising. I'm looking for the change in height with respect to time. That's what I want to know. And I want to know this at the instant the water is 2 meters deep. What's 2? The height is 2. Okay, so if I say the water is 2 meters deep, I means I'm standing in 2 meters of water. That's the height. I hope I'm taller. Okay, so how are we going to find this relationship between h and r? Because h and r are both changing. Ooh, and volume's changing. I guess, how do we find a relationship between volume and height? Well, the volume for a cone is equal to 1/3 pi r squared h. Okay, so that gives us a relationship between volume and height. I definitely need a relationship between volume and height. And if I just went with my method before, I'd take the derivative of both sides with respect to time. And do you see where I'm going to come into a problem? I've got 1, 2, 3 variables here, and I'm going to introduce time, a 4th variable. And what process of differentiation do I need here? When I have 2 variables multiplying each other, I need a product rule. So before you start making this way harder than it needs to be, do you see that you have some similar triangles? in this cone. That is 5, the height, is to 3, the base. What the height is to the radius. So we've got this right angle, right angle. So 5 is to 3 what h is to r. So take this and solve it for the variable that you don't want to be working with. So solve this for r so that you can substitute. That is, r is equal to 3h over 5. Take this and put it in here. Volume is equal to 1/3 pi, or pi by 3, and r squared h. What's r? It's 3h over 5. Okay, just like those optimization problems, if you simplify before you start, everything is so much easier. Simplify this completely. You're going to get volume equals 3 squared is 9 times pi h squared. So I've got 9 pi h squared times another h gives me h cubed over 5 squared, which is 25, times 3. So once again, I've got pi times 3 squared times h squared times h over 5 squared times 3, which simplifies to volume equals, 3's cancel, 3 pi over 25 h cubed. Okay, from here, it's fairly simple to take a derivative with respect to time of both sides of our equation. Just remember that this is a giant constant, and you don't need to worry about it. Just leave the constant out in front. Derivative with respect to time, 3 pi over 25. The derivative with respect to time for h cubed, 3h squared, dh by dt. So simplifying that, then I get 9 pi over 25h squared. So dv by dt is equal to 3 times 3, 9h squared. Oh, sorry, I missed out the pi. I'll just finish writing this down. Okay, and I'll let you guys finish that and adjust your homework. Just so that you know what you're looking for, you end up with a solution of 10 over 9 pi. I'll let you write out a sentence to answer the question, or 0.35, and it should be meters per minute. Meters per minute is your units. And I'll give you your homework.